This is Precalculus section 6.4, and we're going to be discussing the law of sines. The law of sines is used to solve primarily oblique triangles. And oblique triangles are triangles that have no right angles. The past few days we've been dealing with solving special right triangles and other right triangles. And the law of sines can also be used to solve right triangles, but primarily we use them for oblique triangles. A review of geometry, discussing congruent triangles. Methods to prove two triangles are congruent include ASA, short for angle, side, angle, side, angle, side, angle, angle, side, 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 and hypotenuse, leg. We cannot prove triangles are congruent by knowing the side, side angle or angle, angle, angle. The law of sines is used to solve a triangle when the given information satisfies angle, side, angle, angle, or side, side, angle, which is called the ambiguous case. The law of sines tells us if we have a triangle ABC with opposite angle A is opposite of leg A, angle C is opposite of leg C, and angle B is opposite of the side length B. The law of sines tells us that the sine of A divided by A is equivalent to the sine of B divided by little b, and it's also equivalent to the sine of C divided by C. This is always the case for any triangle, as long as you are given either angle, side, angle, or side, side, angle. So for our first example, it asks us to sketch a triangle and then solve the triangle using the law of sines. If we are given the measure of angle A is 22 degrees, we're given the measure of angle B is 95 degrees, and we're given the side length A equals 420 units. This given information satisfies side, angle, angle, so therefore we know we can use the law of sines. To find the side length of B, so little b, we can take the sine of A divided by little a, and set that equal to the sine of B divided by little b. Since angle A is equal to 22 degrees, you just write sine of 22 degrees, and since the side length of A is 420, we divide that by 420, and that is set equal to the sine of the angle of B, which the angle of B is 95 degrees, so sine of 95 degrees divided by little b, because we were trying to find little b. Now if we multiply by b on both sides, multiply by 420 on both sides, we are left with b times sine of 22 degrees equals 420 sine of 95 degrees. Dividing by sine of 22 degrees on both sides, we are left with b equals 420 sine of 95 degrees divided by sine of 22 degrees. When punching this into your calculator, you're left with b equals 1,116 and 9/10. Now to find the side length C, some people may think we could do the Pythagorean theorem, because we know the other two side lengths, but since we do not have a right triangle, we cannot use the Pythagorean theorem, so we must use law of sines again. So we can use sine of A divided by A equals sine of C divided by C. We know that sine of A is equal to sine of 22 degrees divided by, since the angle or the side length A is equal to 420, it's divided by 420. And that's equal to, to find the angle for C, we take 180 minus 95 degrees minus 22 degrees, and that gives us an angle measure of 63 degrees. So the measure of angle C is equal to 63 degrees. So sine of 63 degrees divided by C. Now multiplying by our denominators on both sides, we are left with C times sine of 22 degrees equals 420 times sine of 63 degrees. Subtracting by sine of 22 degrees on both sides, we're left with C equals 420 sine of 63 degrees divided by sine of 22 degrees. Typing this into your calculator, we are left with C equals 999. The law of sines can be used to solve any triangle, whether it be a right triangle or oblique triangle, as long as we are given angle, side angle, or side angle. On the first slide, I just brought up the ambiguous case that can occur when using the law of sines. When you are given information that satisfies side angle, you could either make no triangle, you could make one triangle, or you could make two triangles. And we'll see this more in an example. So looking at example number 2, this asks us to solve the triangle using the law of sines. Notice that we are given side angle. So if we are trying to, let's say, solve for the measure of angle B, we can say sine of A divided by A equals sine of B divided by B, which is equivalent to sine of 135, since the measure of angle A is 135, and since the side length A equals 100, that's divided by 100, that's equal to sine of B, which B is unknown, divided by the side length B, which is 80, and that'll be is equal to 80. So in multiplying by the denominators on both sides, we are left with 80 times sine of 135 equals 100 sine of B. So dividing by 100, we are left with 80 sine of 135 divided by 100 equals sine of B. Then we can take the sine inverse of both sides. So B equals sine inverse of 80 sine 135 divided by 100. And in our calculator, this is equal to 34.4 degrees. Measure of angle B is 34.4 degrees. So now we know the measure of angle C. We can find that by taking 180 degrees and subtracting off 135 and subtracting off 34.4 degrees. This is the measure of angle C is equal to 10.6 degrees. So now we can find the missing side length C by just taking sine of A divided by A and set that equal to sine of C divided by little c. Since A is the measure of angle A is equal to 135 degrees, we have sine of 135 divided by 100, and that's equal to sine of 10.6 degrees divided by little c. Now to solve for c, we just multiply by the denominators on both sides, so we are left with c times sine of 135 equals 100 sine of 10.6 degrees. Dividing by sine of 135, we are left with c equals 100 sine of 10.6 degrees, all divided by sine of 135 degrees, and this is equal to 26. So the side length C is equal to 26. Now we can ask ourselves, is there a second triangle for example number 2? We want to use the first angle we found, which is the measure of angle B, which equals 34.4 degrees, to help us decide if there is a second triangle. We found that sine of angle B is equal to 0.5657, and sine is positive in quadrants 1 and 2. So angle B could either be equal to 34.4 degrees if it was in quadrant 1, which is the angle that we already found, or an angle in quadrant 2, which would just be the measure of angle B, which equals 180 minus 34.4, which equals 145.6 degrees. Now we have to ask ourselves, can angle B equal 145.6 degrees? We have to think of the information that we were given. We were given side angle, where the angle we were given was 135 degrees. So if we're given that angle A equals 135 degrees, because it was given, and we can add angle B, which would be 145.6 degrees, and that ends up equaling 280.6 degrees. 280.6 degrees is greater than 180 degrees, and we know that a triangle can only have, or the three angles of a triangle can only add up to 180 degrees. So since 280.6 degrees is greater than 180 degrees, this means that there is not a triangle, a second triangle, for example, number 2. If this number, 286 or 280.6, if that number happened to be less than 180 degrees, then we would have a second triangle, for example 2.